Okay, so today we're looking at what are the properties of exponents. So how do we use them? Well, the first property that we're going to talk about is the property of powers. Okay, so if I have two things with the same base, such as a to the m times a to the n, so they have the same base and different powers, all I have to do is add those powers. Now I'm going to show you where that comes from. X to the fourth. What is x to the fourth? X to the fourth is just x times x times x times x. Right? That's x to the fourth. X squared, so this is being multiplied by x squared. Well, x squared is just x times x. Right, so we have x to the fourth times x squared. Well, how many x's do you have there being multiplied together? 6. So that's x to the sixth. Right? So that's the exact same thing as x to the 4 plus 2. So we don't have to write all this out. If it's the same base to different powers, we just add the powers. 4 plus 2 is 6. Okay, so the next property that we're going to look at is the power of a power property. It says that if you have a to the m and all of that to the n, that's equal to a to the m times n. So you just multiply the powers. Now, let's see why that works. X squared to the fourth. That means I have x squared, which is x times x, 4 times. So x squared times x squared times x squared times x squared. Now how many x's do I have being multiplied with each other? 2, 4, 6, 8. So this is x to the 8th power. But since we saw that it was 2 to the x squared to the 4th, we could have just done 2 times 4 is 8. So let's try another one. Let's try x cubed cubed. So this is the same thing as x to the 3 times 3, which is x to the 9th power. Power of a product is whenever we have two things or multiple things inside of the parentheses. All that happens is that whatever it's all being raised to, everything gets that exponent. So a times b to the m becomes a to the m, b to the m. Okay, so let's look at why that happens. xy squared. xy squared means xy times xy. Well, since all these things are being multiplied, I can write them in any order. That's the same thing as x times x times y times y. How many x's do you have there being multiplied? 2, so that's x squared. And how many y's? Times y squared. Alright, let's do an example of 3x cubed squared. So now I'm starting to mix in some other properties. First of all of the 3x cubed is being squared. So everything is going to get that squared. That's 3 squared times x cubed squared. Well, in the power of a power property, I know that with this 3 and 2, I just multiplied 3 times 2. So now 3 squared is 9, and then x cubed squared is x to the 6th. Now, if I wanted to, I could have written all of that out. 3x cubed squared would be 3x cubed squared, right? X. So it happens twice. And now what's 3 times 3? 9. How many x's are there?
6.
So it's the same thing. The properties just let me shorten what I'm doing. Okay, quotient of powers. Remember, if we had a to the m times a to the n, you would add the exponents. For quotient, you can subtract the exponents. This works because, let's look at x to the fourth over x squared. X to the fourth is x times x times x times x over x squared. Okay. If you have something in the numerator and it's in the denominator, they're all being multiplied, they can cancel. So let me change the pin here. Okay. So this x can cancel this x. This x can cancel this x. And what am I left with?
2x, so it's x squared.
Yeah, I'm left with x times x, which is x squared. Sorry, I had the wrong color. So the other way I could have done that was x to the 4 minus 2, which is just x squared. Okay, well let's try that. Let's do x cubed y squared over x to the 5th y. Okay, so we haven't talked about the negative exponent yet. So if I use my actual quotient of powers, then I'll have 3 minus 5 is negative 2, but it's not proper to leave an exponent negative. So whenever we divide, we almost always just want to go ahead and write it all out. Okay? Whenever you divide, go ahead and write it all out. So we have x cubed, and then I like to keep my things together, so x to the 5th will go right underneath. And then y squared, y. So I've separated them out because this is going to make it easy for me to cancel. These x's all cancel, and these y's will cancel. Now in the numerator, all I have left is a y, and in the denominator, I have x squared. Okay, if we have a negative exponent is pretty much just saying, hey, if I'm in the numerator, I belong in the denominator. Or if I'm in the denominator, I belong in the numerator. I'm in the wrong spot, right? So a to the negative m, that's the same thing as saying, okay, I should have been in the denominator, and that's 1 over a to the positive m. Or 1 over a to the negative n, it's in the wrong spot. Let's move it up to the numerator, a to the n. All right, so we're going to do an example of that. Let's do x squared y to the negative 2 over x to the negative 3 So I have two variables that have negative exponents. So I'm just going to move them. So the x squared didn't move. Now, the y to the negative 2 moves to the denominator and it becomes positive, like y to the positive 2. And that x to the negative 3 moves to the numerator and becomes x cubed. Well, now I have x squared and x cubed. So same base, different exponents. How do I? Or it doesn't even matter if they're different exponents. Just this x to the 2 plus 3. So yeah, there's 5 x's up there being multiplied by each other over y squared.
That's it?
All right, the power of a quotient property is just like with multiplication. If you have a parentheses, every single thing inside the parentheses gets the exponent. So a over b to the m is a to the m over b to the m. Now, if I wanted to just write it out, where that came from, x over y squared is the same thing as x over y times x over y. Well, that's just x times x over y times y. Right? Like this?
Right.
So that's just x squared over y squared. Everything inside the parentheses got the power. All right, let's try it out. Let's say that I have 3 over x squared raised to the negative 2 power. Okay, so what's about to happen is every single thing inside this parentheses is about to be raised to the negative 2 power. Now, whenever you're raised to a negative power, that just means that you're in the wrong spot, right? If you're in the numerator, you should be in the denominator, vice versa. So what we can do is anytime that we have a fraction raised to a negative power, we can rewrite this as just go ahead and flip the fraction, and now this is a positive 2. Okay, so yeah, if a fraction is raised to a negative power, you can flip the fraction and then change the sign of the power. Now, let's apply our property. Everything inside the parentheses is raised to the power of 2. So x squared is now raised to the power of 2, and 3 is raised to the power of 2. Well, x squared squared, that's power of a power. Power of a power, we multiply the exponents. So that's x to the 4th, and then 3 squared is 9. So x to the 4th over 9. Okay, the last property that we're going to talk about is the zero product property. A to the 0 equals 1. All this means is any number raised to the 0 power is 1. Okay? So, like real quickly, like x to the 0 equals 1. 10 to the 0 equals 1. Right? So, x cubed, y squared, all raised to the 0 power equals 1. Okay, but you have to wonder, why is this true? Right? Well, anything divided by itself is 1. So let's think about that. Let's think about x cubed over x cubed equals 1. Well, whenever we separate this out, yeah, everything cancels. If everything cancels, you don't have 0 left. You have 1. Okay, because remember, canceling with multiplication, you're left over with 1. It's not like canceling with addition and subtraction. So, if I think back to my quotient rule, x cubed over x cubed is the same thing. I can just subtract the exponents as x to the 3 minus 3. Well, 3 minus 3, that's x to the 0. And that's why anything to the 0 power equals 1. All right, now we're just going to do a couple of examples. In this first example, we have x squared, y to the negative 2 over x cubed, all of this raised to the power of 2. Now, you can either give everything this power of 2, like distribute, the power of a power and the product of powers, whatever. Or you can simplify inside the parentheses first and then square. It doesn't matter. So I think it might be easier for us if we simplify inside the parentheses first. So inside I have x squared. What's going to happen to that y to the negative 2?
Go to the bottom.
It's gonna move to the bottom. And now it's y squared. And then the x cubed stayed down there. If I have x squared over x cubed, well then, these two x's get canceled with these down here, right? I could have written out the y's, but since no y's are going to cancel anything, I didn't. So like, I look down here, I'm like, okay, these cancel. What do I have left in the numerator? What's left in the numerator?
Nothing.
Not nothing. Whenever what's x divided by x?
Negative.
X divided by x is 1. So I have 1 over xy squared. Okay? So be very careful about that. Now that we have just the most simplified inside the parentheses, let's give everything the squared. That's 1 squared over x squared times y squared squared. What's 1 squared? 1. The x squared is still x squared. And then y squared squared. It's power of a power, so we multiply 1 over x squared y to the 4th. All right. The last one I'm going to look at is 4x cubed x over y to the negative 1, all to the negative 2 power. Just like last time, I'm going to start by simplifying what's inside the parentheses first. So 4 times x cubed times x is 4x to the 4th. And then that y to the negative 1, it's saying, hey, I'm in the wrong spot. I should be in the numerator. So it's going to move up and become y to the positive 1. So I don't have to write to the positive 1, but you can. Okay, now I can either flip everything inside the parentheses and change the sign of the outside, or just give the negative 2 to everything. But just to keep in line with the notes that I've given you, I'm going to say, okay, that's the same thing as 1 over all of those things to the positive 2. Now, everything inside that parentheses will be squared. So 1 squared over 4 squared, x to the 4th squared, y squared. So my answer is 1 over 16. X to the 4th squared is how many x's? That'd be x to the 4th times x to the 4th, which is x to the 8th. You get that just from doing 4 times 2? And then y squared is just y squared. Alright, and that'll wrap it up for properties of exponents.